So I'm Prashanthi Vemuri, and I'm from Mayo Clinic. I'm a trained neuroimager who's been studying the brain using images and trying to understand aging and dementia. A little bit of a background about me. I am a co-PI on Mayo Clinic study of aging, and this was a study started by Dr. Ron Peterson, and the goal is to recruit non-weird samples. So our goal is to recruit population-based samples, which is we randomly sample the populations and we try to understand and recruit everybody, invite them to participate. Some people decline, but we try to be representative and back project our frequency numbers of changes that we see back onto the population. So we try to be as non-weird as possible. And the focus that I have is studying imaging changes in individuals to try and understand aging and dementia. One thing right off the bat is when you look at images of individuals, you will see a 85-year-old individual who has a lot of amyloid tau, but really performing at cognitive levels of a 60-year-old. You're always surprised. There's a lot of heterogeneity in what you see in the population. And the focus of my program is twofold. One is, overall, it is to understand how some people are able to exceptionally age. You could do that by measuring really early changes, as well as investigating the protective and risk factors that drive these changes in order to move towards prevention. So I'm going to talk about three things today. One is convince you guys, you're probably already convinced that there are multiple pathways to cognitive impairment. And this is important to consider when you're looking at race, diversity, and SSDH. And how do you come up with approaches to reduce risk across the population? And what are the important challenges and considerations that we have going forward? Beginning with multiple pathways to cognitive impairment, pathology literature has always guided us of where we are. So starting in the early 1980s, Yaka was part of one where there was a lot of interest on what is the pathology when someone dies. It was the gold standard. And you see quite a bit of heterogeneity in what you see in the brains. And I'm going to focus on two of the pathologies, Alzheimer's disease pathologies and cerebrovascular disease. So as you can see, cerebrovascular disease disorders are very, very common. And to put them in different pathways is important when you're looking at race, diversity, and social discriminants of health. The reason is why is because their genetic differences as well as propensity to disease is very different across populations. ApoE4 gene, which represents a genetic risk for Alzheimer's disease, is 24% in the white populations. But in South Asian population, the prevalence is 7%. But cerebrovascular disease is extremely high. If you look at some of the Indian studies, you'd see that the risk of developing cerebrovascular disease, stroke, is extremely high. But all these paths lead to cognitive impairment because they contribute to overall poor health. And focusing on these two aspects of aging and dementia is very important because if you take a 75 or an 80-year-old individual in our study who does not have any symptoms, performs really well, if they do have Alzheimer's disease, early signs of Alzheimer's disease or cerebrovascular disease, they're bound to decline really fast and move on from the category of cognitively impaired, unimpaired to impairment within the next 5 years. So studying these two categories and what can we do to reduce the risk of both the pathologies is very important. So I'm going to talk about multi-pathways to cognitive impairment. We need multifactorial approaches for prevention. How do we prevent or resist against amyloid and tau? How do we avoid cerebrovascular disease? And how do we maintain brain health? So I'm going to talk about three examples that try to get you to the point that there are multiple approaches to prevention, and we need to look at it, zoom out, and look at it more holistically of how do we get there. So this was a very early study that we did, which basically showed that if you are highly educated, you're 90 years old, 80 years old, you do a lot of cognitive activities, you have a lot of social connections, your time to cognitive impairment is about 10 years. But if you have low education and you do not engage in a lot of cognitive activities, group activities, then your risk to impairment is about 2 years. But we know all this. So why do we really need to understand risk reduction from the perspective of biomarkers? Why do we really need to understand mechanisms? And I'm hoping to make the case with these three examples that I show. The first example is tau is a protein. Abnormal deposition of tau causes impairment because of Alzheimer's disease. It's often said, and it's widely shown in the last 5-10 years, is that if someone has amyloid because of the amyloid cascade, everyone with a positive amyloid scan is likely to decline in the next 5 to 10 years. But that's not true. There are a lot of 8-year-olds who have amyloid, head full of amyloid, don't decline over 10 years of time. So why is that? So how are that? There are some red circles, as you can see, at the bottom, who have positive amyloid scans, but they don't have amyloid abnormal tau, even if you wait long enough. So there are two things that we have looked at in the lab, in our lab. One is better stress coping strategies are associated with lower tau in amyloid positive people. So I'm going to ask you a question. How many here either exercise, either meditate, or think about your stress levels really well? So how many of you do that? So it looks like all the weird samples, right? Highly educated people really think about better stress coping strategies. So we are well educated, we have access to resources, and it seems like people who have higher on brief resilience scales are people who are meditators, who exercise, who do a lot of things to compensate for your stress levels. So this is access to material and to be able to be treated. The second example that I wanted to do is some studies that were done by Diego Carvalho in my lab, and he has looked at sleep in multiple different ways, how sleep affects longitudinal amyloid deposition. But this is the simplest approach, which is people have witnessed apnea. So when you're sleeping, there's short times where you stop breathing, less oxygen to the brain, less deep sleep, right? People who go and get it looked at are usually highly educated people. And if you have witnessed apneas, you definitely have high risk of getting tau deposition. There are two mechanisms that explain that. One is the clearance, and the other one is less synaptic activity and less tau release. So both of these can be looked at if people are treated earlier. So we are giving out watch pads in our study and piloting a study where we're trying to figure out who are the people who have undiagnosed apnea. You will be surprised when the number of people who have undiagnosed apnea. Sleep problems are a big issue, and addressing, like Audrey said, is very important across racially diverse populations. The second thing is targeting cerebrovascular disease. Often you see that both African American, Asian, indigenous populations have high risk of stroke and changes to the brain because of vascular disease. It could be higher white matter hyperintensities, changes to the brain, microbleeds, infarctions. And we have to realize that if you have any of those, you have a high risk of impairment in the next 5 years. And one could actually say, it's too late. By the time we see people, it's too late. They have microbleeds already, and so on. But the question is moving it backwards. A very nice overview on cerebrovascular disease was published by Dr. Joanna Wardlaw. And the crux of the paper, one of the points they make is there are very subtle changes in the brain, even before you see tremendous changes, even before you see visible changes. So we did a study where we tried to say, took people from ages of 50 to 90 years old and said, how are the white matter changes happening in these individuals? And we find that clearly at the bottom, you can see cluster 4, where you see people really declining very fast. Their white matter goes from normal to abnormal very fast, longitudinally. And so looking at white matter changes early on in midlife is very crucial to try and prevent changes in the future. So this is one of the pathways, one of the multiple pathways to target. This is a nice causal study that shows it's kind of a interesting study because it shows that, oh, you exercise, yes, your weight is better controlled. So the arrow going from physical activity to BMI, you have lower risk of hypertension. All these come together. You don't smoke, then you have low risk of hyperintensity. So your white matter health or risk of cerebrovascular disease could be targeted through multiple pathways, and all of them come together to try and reduce the risk of cerebrovascular disease. The third example is we underestimate the importance of maintaining brain health in midlife. So we ran a study where we said, okay, if you're healthy, you have optimal brain health in midlife, you're more likely to actually resist or be resilient against later age-related disorders. So you typically before the age of 65, you don't see any age-related pathologies in the brain. So you do not see a lot of Alzheimer's disease pathologies, cerebrovascular disease pathologies. And we said, who are these people who have really healthy brains, optimal brain health? We looked at multiple things. We looked at metabolism, we looked at microstructural integrity and structure. And what we found is general health status. So people who have really clean clinical labs seem to be the ones who have better brain health in the future. But who are the people who are going into regular healthcare systems, who have access to healthcare systems, having their tests done? There's a real bias in who are able to maintain optimal brain health versus the access to healthcare that is given. So is it really difficult to achieve all these list of things that are multifactorial? The answer is no. The biggest success story has been the blood pressure control. And what they've seen across 7 studies across Europe and US is that there's a projected decrease of 13% of incidence of dementia by the decade of 2040. And the projected reason is that we're increasingly aware of controlling our blood pressure and treating hypertension. And that's contributing to lower incidence of dementia over the next few decades. So we could get there. So in summary, 3 challenges or considerations as we look at the cognitive impairment and dementia and trying to prevent it. The first is we need to accept that it's complex, heterogeneous. We need to address multiple different paths that get to it. So other pathologies, cerebrovascular disease, maintaining optimal brain health, genetics plays a big role. Gene expression plays a big role. We need a broad framework. We cannot focus on one particular aspect, but education and access lies at the top of multiple different things that path down to the mechanisms that cause poor brain health and cognitive impairment. We need to look at early cost-effective screening. What we find is in people who are less than 65 years of age, if you have their vascular risk and if you see changes in their gait speed, that's very predictive of vascular disease that they may have in the future. So just to end on this, multifactorial approaches are important. We need a broader framework, and we should move towards early cost-effective screening so we can detect early changes to the brain and prevent further damage down the road. Thank you.